Hello. So this is proving triangles congruent, and it's proofs using that. So by the end of this module, you'll be able to prove triangles congruent using clarity and precision in your language. So what is a proof? A proof is an explanation of why something is true. So a proof explains everything that you see, and it starts off with what you know. Okay, so in each case, you're going to be given something, and that's your starting point. And then you have to prove why a triangle or prove why an angle is congruent to another angle. So why is this true? Okay, so there's two methods of doing this. You can use a two-column proof, or you can use a paragraph proof. I personally like paragraph proofs because it's more in line of your thought process or your thinking. And I will show both methods. But no matter what, you always start with what is given. So this section here is your first piece that you are going to write. So in a two-column proof, you would have your statements on one side and your reasons on another. So the statements are one by one. So the first statement I'm going to make is segment AB is congruent to DB because it is given. And I am going to say that C is the midpoint of AD because it is given. Now, this right here is what I have to prove. So that is the last statement I'm going to make. So I have to go by these two things that I know. Now, AB is congruent to DB is already marked here. Those are the sides that are marked. Now, what I can notice in this is that there's this shared line in the middle, BC. So before, we would just mark this congruent because it's shared, and you didn't have to explain your reasoning. Now, you would say BC is congruent to BC because it is a shared line. That shared line, it's also called the reflexive property. It's equal to itself. It's in both triangles. That's what the reflexive property says. So now I have two sides. And what I have to do is I have to decide, can I find an angle or can I find something else? Well, that's where terminology comes in. And that reason right there. Midpoint, if you remember back to Unit 2, midpoint cuts a line into two equal parts. So when it says that C is the midpoint of AD, this point right here in that triangle cuts this whole side into two equal parts. So this side is equal to this side. So AC is congruent to BC because C is the midpoint. So every time you see the word midpoint, you have one side equal to the other side. So that is a key vocabulary term that you're going to have to remember when you are proving triangles congruent. But now what you notice is that I have three sides, the green, the orange, and the blue, that make these triangles congruent. So triangle ABC is congruent to triangle DBC by side, side, side. So it's taking the visual and actually writing down what you know. And that is through your communication. In my next example, again, I always start off with my givens. So I know, and I will do this paragraph proof, I know AB is congruent to CD, and AB is parallel to CD because it is given. Remember, those lines mean parallel. Now, when I see the word parallel, you have to remember that congruent angles are created. Corresponding, alternate interior, alternate exterior. Those are all congruent angles. So that is something that you have to remember again. But you can also see, this is going to be my last sentence, proving something. But I again have this shared side. So what I'm going to say is AD is congruent to AD because it is shared. So now I have this. Now, parallel lines give me angles. Now, what is parallel? That means that you will see these arrows. That's what it means to be parallel. Those arrows mean parallel. And whenever you see that, and you see this letter Z that gets created, if you see that letter Z, or it could be flipped the other way, this angle is congruent to this angle because they're alternate interior angles. So going back to our angles pair unit, alternate interior angles of parallel lines are congruent. So in my proof, I would say angle BAD is congruent to angle CDA because they are alternate interior angles. Once I have that, I have a side, I have an angle, and I have another side. So I can say triangle ACD is congruent to triangle DBA by side, angle, side. I am proving those triangles congruent using reasons. So that is a simplified version of a paragraph proof. In example 3, again, I will do this using both 2-column and paragraph proof. So I always start off with what is given. So in my 2 columns, BC is congruent to EC because it's given. Angle B is congruent to angle E because it is given. In a simplified paragraph proof, I would write, I know BC is congruent to EC, and angle B is congruent to angle E because it is given. So I have right now an angle and a side in both triangles. But whenever you see that X being created, or what I call the hourglass of these triangles, I've been expressing that these angles right here are equal to each other because they are vertical. So what you would state would be angle ECD, this angle right here, remember 3 letters, is congruent to angle BCA because they are vertical. So in paragraph, it would be angle CDE is congruent to angle BCA because they are vertical. Now you can notice that I have the theorem angle side angle in both triangles. So I can say triangle ABC is congruent to triangle DEC by angle side angle. Same thing here. Triangle ABC is congruent to triangle DEC by angle side angle. So that is a simplified paragraph proof and a 2-column proof right in a row. Remember, you always have to start off with your given, and then you actually have to explain why you can mark the picture. Now you're just not marking the picture, now you have to explain why you are. And that's the only difference between what we've been doing in the past, in the previous model, and what we are doing now. You have to explain the vertical angles, the alternate interior angles, and the midpoint. For the next few problems, they continue through. Again, you are given certain things, and now you have to prove the triangle's congruent. You can either use a 2-column proof or a paragraph proof, whichever fits your methodology the best. Come in next class with any questions, and thank you for listening.